Hello, everyone. We are in lesson 3 of our accelerated units. We are learning how to convert to radians. So we're going to be discovering how to go from degrees to radians. For those of you guys who kind of already get it, this is a simple idea. Our degrees over radians will equal our 180 over pi. We get that 180 over pi by doing 360 divided by 2 pi, which leaves us with only 180 over pi. We're going to be answering these questions, and we're going to see how we can discover converting our degrees to radians through each of these problems. So in this first problem, we have two circles, circle D and circle E, both with a arc sector of 30 degrees, but with different radii. One with a radii of 3, and one with a radii of 5. Our first question is, what is the length of the marked arc for each circle? Leave our answers in exact form, so in terms of pi. So to find that, what we're going to do for each one is we are going to get our 30 degrees and divide by 360. 30 over 360. And for our radius of 3, we're going to do we're going to multiply 2 pi times our radius of 3. So we're doing our circumference. We're pretty much doing the crust. And this is going to give us pi over 2. Just so you know, I do 2 times 3, which is 6. 6 times 3 is 18. And then that becomes 180. 180 over 360 is pi over 2. Now we do the same exact thing for our other circle. So we're going to get 30 over 360 times 2 pi, except times 5 this time. And you can kind of guess what's going to happen with this to a degree, but we're just going to go ahead and multiply, and we are instead going to get 5 pi. There we go. 5 pi over 6 units. Both of these are in unit form. And that's when we get A. Now, these problems actually go pretty simple. Again, for this one, we're just looking at the arc length of the crust, but now we're going to look at the ratio of the arc length to radius. So we're going to find the actual area. What we're going to do is, we're going to find the ratio, and what we're going to do that is we're going to get pi over 2. So that's our answer for circle D, pi over 2. And then what we're going to go ahead and do is we're going to divide that by our radius, 3. This is going to help us find a ratio. This will give us pi over 6. And now what's important about this is for part C, they ask us a very similar question. They will ask the exact same thing with circle E. So instead we're going to do 5 pi over 6. And we're going to divide that by 5. Doing this will also give us pi over 6. And what we notice is both of these guys give us the same radius, the same exact ratio. And so the ratios are equal. So in the next one, you say, hey, what if we have a radius of 100? Can we get the same ratio? Well, we can. We would do 100 pi over 6, and then we would divide that by 100. And I think you see where this is going. We divide this by 100, and we also will get pi over 6. Let's slow this down a little bit. Now, what that leads us to is radians. Essentially, anytime we have 30 degrees, we're always going to have pi over 6 radians. We're going to look more into this in a second, but right here, we can see that our degrees and radians, zoom in here. If we have something like 60 degrees and we wanted to find the radians, we would simply cross multiply and multiply 60 by pi, and we would divide by 180 to get ourselves pi over 3 radians. And that is similar to this guy. So, for example, we don't really look at our radius when doing this. Our radius isn't included. We only really need our degrees in 180 over pi. So, for example, if we have 30 degrees and we have 180 over pi, again, we want to find our radians, which is x. We cross multiply, we get 30 pi over 180. And that will equal x. And then 30 is 1/6 of x, so that proves that we have pi over 6 for our radians. And that is how we convert from degrees to radians.